Right, hello. This is lesson 15 now, and it's going to break it up into three separate parts. Now, the first part is let me get the speed, density, and pressure. So, this first part of lesson 15 is now broken down into three subsections, and the first one is to do speed. Now, we've got part of speed is going to be the speed, the distance, and the time. Okay, so first of all we need to know the relationship between all these things. So let's draw a little triangle to help us remember. And this little triangle, speed, distance, time. Now what we can do with this is the speed equals the distance divided by the time. Distance divided by the time. The time is equal to the distance divided by the speed, and the distance equals the speed times the time. Yeah, so you can use the little triangle to get all three equations to what you're trying to do. So let's have a look at a couple of questions. A car travels 9 miles at 36 miles an hour. What that's the car travel, so that's the distance, that's the speed. What not what, but how long did it take? That's better. How long did it take? Okay, so we've got the time is equal to the distance divided by the speed, and the distance is 9, the speed is 36, and that is equal to 0.25. 0.25 what? Now this is in hours, so it's going to be 0.25 hours, which is a quarter of an hour, which is 15 minutes. Okay, 15 minutes. So let's come down. So as long as you remember that triangle, now we're going to write it down all the time. Now let's have a look. So if you travel 10 miles at 8 miles an hour, how long did it take? How long? So we need the time equals the distance divided by the speed. The distance is 10, the speed is 8, and that equals 1.25 hours, which is 1 hour and 15 minutes. Good. Now if you get an answer of something weird like this, 1.4 hours, that isn't 4 minutes, that isn't 40 minutes, it's 0.4 of an hour. So you know it's going to be 1 hour, and the other bit is going to be 60 times 0.4, which equals 4 6 24. So that's going to be 1 hour 24 minutes. So you have to convert the decimal into minutes. Yeah. Now the second part of this is density. Now density is to do with mass and volume. Now mass is usually in density questions, it's just kilograms or grams. Yeah, we're not worried about, it's just weight really. So we need another little triangle now here to calculate. So we've got the density and the volume and the mass. So we've got the density equals the mass divided by the volume equals the mass divided by the density, and the mass equals the density times the volume. Yeah, so you've got all three possibles there. So let's come down a wee bit. So a chocolate bar has a density of 1.3 grams per meter. What's it? Volume, meter cubed, isn't it? Volume. So density is 1.3. G is the mass, and m cubed is the volume. So you've got density equals mass over volume. So in the question, they've given you what the formula is that you need to use. So they tell you that the volume is 1800 centimeters cubed. Oh, that is centimeters, sorry. Centimeters. Don't want to be messing with different kinds of razor, large eraser, because we made a large mistake over centimeters cubed. Right, so how do we do this? We need to know the question, which is we've got the density, we've got the volume, so we need to find the mass. So the mass is equal to density times volume, 1.3 times 1800. It's all in centimeters, so we're fine. No changing, no awkwardness. And so we've got 1.3 times 1800. Let's have a go at that on the calculator. 1.3 times 1800 equals 2340. 2340, there we go. 2340 watt. Grams, of course, because grams is there in the density. Right, so the third one of this is pressure. And pressure involves pressure, obviously, force, and area. So it's how much pressure you can put on a certain area. If the area becomes smaller, then the pressure becomes bigger if the force is the same, so on and so forth. Right, so again, one of these little triangles. Yeah, there's three of these little things, nasty little things to try and remember. So we've got pressure, we've got force, and we've got area. So what can we do? So force is either going to be in kilograms or grams, or it can be in newtons. It's correct to have it in newtons, but I'm not too sure. It should be in physics, yeah? So we've got a barrel. And the barrel is a cylinder, and the radius, with a radius of 0.4 meters. Right, and the weight of the barrel, or really the weight of the barrel, yeah, the weight of the barrel is 200 newtons. See, weight, force, kilograms, newtons, all gets a bit muddly with this one. Calculate the pressure. So pressure, P. So P equals F divided by A. So the force is 200, the area. We've got to work out the area now. Quick! Area of a circle, because the barrel is this shape, yeah? Area of a circle is pi r squared, which is, I'll call it 3.14 times the radius, 0.4 squared. Quickly zip that into the calculator. So 3.14 times 0.4 squared is equal to, call it 0.5, yeah, 0.5. So 200 divided by 0.5 equals 400. And what's pressure measured in? According to this question, it's going to be newtons per meter squared. Newtons per meter squared. So not bit tricky. This should be in physics, but it's not. It's in maths. So there you go. That is the end of